In this case, we separate the fraction on the left into two fractions, or the sum of two fractions. Our first denominator comes from the first factor, x minus 3, and the second denominator comes from the second factor, x plus 5. And we don't know the values of the numerators, so we call one of them a and the other one b. Now, just considering the right hand side, when we add fractions, we need the denominators to be the same. So to do that, I'm going to multiply this fraction here by x plus 5, so that the denominator will be the product of x minus 3 and x plus 5. And I'm going to multiply this fraction here by x minus 3, top and bottom, so that the denominator here will be x plus 5, the product of x plus 5 and x minus 3. So let's do that now. So if we have the left hand side staying the same, the right hand side becomes a multiplied by x plus 5 all over x minus 3 x plus 5. So the value of this fraction hasn't changed. We've just multiplied it essentially by 1, because x plus 5 over x plus 5 is 1. And then we're going to multiply the second fraction by this factor here, x minus 3. We do that on the top, and we do it on the bottom to keep the value the same. And now we can see that actually the denominators are all the same, so we can compare the numerators. And on the left hand side we have 5x plus 1, and on the right hand side we have the sum of these two. In fact, we could write one extra line just to make this a bit clearer. When you have two denominators the same, like we've got here, to find the sum of the fractions, you add the top parts, the numerators. So that's how we get this bit here. Now we can see perhaps more clearly that the numerator here is equal to the value of the numerator here, because the denominators are equal. So let's have a look at this. We've got 5x plus 1 on the left, and if we look on the right hand side and expand the brackets, we get ax plus 5a plus bx minus 3b. Now if we compare the coefficients of x on the left hand side with the coefficients of x on the right hand side, and we'll compare the constants too, it will give us two equations that we can then solve in terms of a, b. Let's look at the x values. So we've got 5x on this side, and here we've got ax plus bx. Or if we take x out as a factor, we've got x lots of a plus b. And then on the left hand side here, our constant is 1, and on the right hand side we've got a constant of plus 5a minus 3b. And if I write it like this, 5a minus 3b, we can see how these parts compare. So a plus b must equal 5, because we've got 5x here and a plus b lots of x here, and 1 must equal 5a minus 3b. So we've got two simultaneous, or a pair of simultaneous equations to solve. Let's check that out then. So 5 equals a plus b, we'll call that equation 1, and then 1 equals 5a minus 3b. Now you need a method for solving these simultaneous equations. For example, you could take this first one and multiply it by 5. So that'd give you 25 equals 5a plus 5b, by taking the first equation and multiplying it by 5. And now we might say, well, actually, let's subtract these two equations. So if we do 5a plus 5b equals 25, and we'll subtract this equation here, which is 5a minus 3b equals 1. Then we have 0a, 5 minus negative 3b, or 5 minus minus 3b is 8b. And 25 minus 1 is 24, which means the value of b is 3. And we already know that a plus b is 5, so a plus 3 is 5, which suggests that a is 2. Now it's good practice to write this out again, but have your value of a written in as 2 and your value of b written in as 3. Here we've split this fraction on the left into the sum of two fractions. Notice we can't just have x plus 2 and x plus 2 here, because the denominators will be the same, so we could just add the top and we wouldn't get this x plus 2 squared. So we've got to have these two separate ones, the x plus 2 and the square of x plus 2. We go through the same method as we did last time. We need to make these the same, but this one is the only one that needs to be multiplied. So the left hand side stays the same. On the right hand side, this fraction here needs to have a square of x plus 2 denominator. So to do that, we'll multiply the numerator by x plus 2 and the denominator by x plus 2, which will give you the square of x plus 2. This already has the denominator that we're after, so we've just got a b there and the square of x plus 2 as the denominator. Now these are the same as I showed you in the previous example. We can just refer to the numerators. On the left hand side we have 3x plus 5, and on the right hand side we'd have ax from the product of a and x, expanding the brackets, and 2a plus b. Now this one's quite nice. We can see straight away that a must be 3 because that's the only x term on the right hand side. So a equals 3. There's 3x there and ax there, no other x term, so a is 3. And now we can look at 5, the constant on the left hand side, is equal to 2a plus b. Well, we know the value of a is 3. So 5 equals 6 plus b, so the value of b is minus 1. And it's good practice, like I said before, to write this out again with a written as the numerator here, the value of 3, minus 1 here written as the numerator for the second fraction. Here, the denominator of the left-hand side, we've got x minus 1 and the square of x plus 4. So there are 3 terms for us to consider on the bottom. That's why I've got these 3 factors here. These two being similar to the last example, and then this extra one from this x minus 1 here. So let's keep the left-hand side the same as we've done previously. Now we need to look carefully at the right hand side. So this one here, the x minus 1, needs to be multiplied, the numerator and the denominator, by the square of x plus 4, so that we get the denominator the same as the left hand side. So this is going to be a lots of the square of x plus 4, and we multiply that by the top and the bottom, the numerator and the denominator, so that will give us the denominator that we want. The second fraction, b, it's already got an x plus 4, so it needs to be multiplied by another x plus 4 to get the square, and by the x minus 1 term as well. And that means that the denominator will be what we want, the x minus 1 and the square of x plus 4. The third fraction has already got the square of x plus 4, so it only needs the x minus 1 term. And that will give us the denominator that we're after. Now that the denominators are the same, we can add the numerators together. On the left hand side, just comparing the numerators, we've got 5x plus 15, and on the right hand side we're going to leave these not expanded for the moment. Now a nice way to work these out is to consider values of x that will eliminate one of these terms, a, b or c. So if we let x equal -4, then this term here will be 0. -4 plus 4 is 0. Square it, still 0. So you get 0a. That term's gone. This term's gone as well. So we've only got this one to consider. On the left-hand side, we'll have 5 multiplied by -4 plus 15 equals, that term is 0, that's 0. So we've just got this one. See lots of -4, take away 1. Left-hand side, -20 plus 15 is -5. And -4, take away 1 is -5. So -5 is -5c. So the value of c is 1. Let's consider another term. Let x equal, well, if we go for 1 this time, then this term here will be 0 because 1 minus 1 is 0. And the product of anything that includes 0 is 0. This term will be 0 as well. So the left-hand side will be 5 multiplied by 1 plus 15. And the only term we're going to get is this one here. That's 0, that's 0. So we've got a lots of 1 plus 4 squared. Left hand side, 5 plus 15 is 20. Right hand side, 5 squared is 25. That's 25a. So a is 20 over 25. Or we'll simplify that to get 4/5. Now to get the value of b, we need to go back to this. And we can't substitute another value in. But what we can do is consider how the terms on the left match or pair up with the terms on the right. So if we take this constant here of plus 15, we think about, well, what do we get here if we expanded these brackets? We would get 16a for the constant. Here we would get 4 multiplied by -1 is -4. We would get -4b for the constant. That is by finding the product of these terms here. And here we would get the product of these, which is -c. So I've written down here what we get on the left-hand side and the right-hand side by considering these bits we've done in green. So we've got plus 15 on the left-hand side. We've got 16a minus the 4b minus the c on the right-hand side. Now we know the value of a and we know the value of c. So we substitute this in. The left-hand side is plus 15. On the right-hand side we get 16, lots of a, which is 4/5, minus the 4b, we don't know what b is yet, minus the c, where c is 1. And if we work this out, our value of b will be minus 4/5. And as I said previously, it's good practice to write this bit out again with the value of a, b and c filled in. I'm going to do that now. Writing it out clearly shows the examiner that you mean business and that you know what you're doing.